Good evening, my dear students. In a previous video clip, already you know about that is EMF induced in a rotating coil in the AC generator. In the AC generator. Finally, what you got the expression here? That you got the expression that is EMF instead of small letter E, you represent the capital letter E. Now that is at any instant of time EMF E is equal to what you say, that is E naught sine omega t, or you say to me E is equal to that is E naught sine theta. Now that is theta is the angular displacement, t is the time taken. Now it cover the angular displacement theta in time t, then theta by t is said to be angular speed. This is said to be angular speed, theta divided by t. Now theta here you have to measured in radian. Theta is measured in radian and t is measured in second here, second, and EMF is measured in what you say, that is a volt, E, or that is E, capital letter E. Small letter E na togoli ಅಥವಾ capital letter E na togoli. It is measured in volt. Now see here how it varies the EMF with a time, or you said to me angle of rotation of the coil in the AC generator. Now you obtain this expression from AC generator. You derive this expression, very important expression for the examination point of view, because it is asked in the examination for 5 mark. What is that question? Derive an expression for EMF is induced in a rotating coil in the uniform magnetic field. You ask the question like this, or you ask the question like this, another type this one. Derive an expression or deduce or obtain an expression for the EMF is induced in a rotating coil in the AC generator. Now ask in the examination that type or this type of expression. Now finally you got the expression E is equal to E naught sine omega t, or is said to be E is equal to E naught sine theta. Now it shows this expression. This expression shows that variation of the EMF in the AC generator or in the rotating coil, it is varies sinusoidally, or is said to be simple harmonically. Now you know this expression for the simple harmonic expression, the displacement at any instant of time, y is equal to a sine omega t. Now this is in PVC first year already you studied this expression, y is equal to a sine omega t. A is said to be amplitude here, and omega is said to be angular velocity, and this is t. Theta is said to be angular displacement. Okay. Now how it varies sinusoidally or simple harmonically, that graphical representation. For different angles, this one 0, 90 degree, 180 degree, 270 degree and 360 degree. You draw the graph of the EMF, or you said to be current along y-axis, and time, or you said to be theta or t, angle of rotation, or you said to be time along that is x-axis, EMF or current along y-axis. How we got this one? For 0 degree it is a 0, it is also 0 current. Now for the 90 degree, you know peak value, maximum value of the EMF, maximum value of the current. For 180 degree again you got 0, and for 270 degree again you got the maximum, but in the opposite direction. This is said to be plus E naught. Now here you said to be minus E naught. It is, you got the peak value but in the opposite direction. It means for each and every 180 degree the current is flow through the armature coil, its direction is reverse, and also it value is varies periodically, or you said to be simple harmonically. For 270 degree again you got minus E naught, minus I naught, and again I will come to the initial position for 360 degree, again it becomes 0, and again this variation is repeats here. Now how we got the alternating current? In next chapter is said to be alternating current. Alternating current. How we got the alternating current? Now see here. Now you observe this one. This EMF is varies sinusoidally or simple harmonically with respect to time. Alternating current, you got the what is the alternating current? That I want to say. Now in the AC generator, that rotating coil having certain resistance, that resistance of that one is said to be R. And EMF induced in a rotating coil, that is said to be E, and current is said to be, according to Ohm's law, E divided by R. E divided by R here. R is the resistance of the armature coil, E is the EMF induced at any instant of time, then R is the resistance of rotating coil. Then you got the current expression, I is equal to what you say, E divided by R. Okay. Now I is equal to E naught sin omega t divided by R. Then I is equal to E naught divided by R sin omega t. Then I is equal to what you got? I naught sin omega t. Now this equation, you observe this expression and this expression. The EMF is very sinusoidally or simple harmonically. No, current is also very sinusoidally or said to be simple harmonically. ಇದು ಹೇಗೆ ವೇರಿಯೇಷನ್ ಆಗುತ್ತಾ, ಇದು ಅದೇ ರೀತಿ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ. Now what is the value of E naught? That is NA omega B here. Value. N is number of turns in the armature coil. Now A is the area of the coil and omega is the angular velocity or said to be angular speed. B is said to be strength of the magnetic field. What about I naught? I naught you got here E naught divided by R. Therefore NA omega B divided by what you say, this is R. This is the expression for current, maximum value of current or said to be peak value of current. You observe this expression, E is equal to E naught sin theta here. Here I is equal to I naught sin omega t or sin theta. This is expression. It is also expression you want to write here. I is equal to I naught sin theta. What theta here? Omega t. Both EMF and current, they varies sinusoidally or simple harmonically. Now what is alternating current? Alternating current andre ಏನು? The current which varies sinusoidally, periodically, and also its direction periodically, such type of current is said to be alternating current. ನಾವು ಅದಕ್ಕೆ ಏನಂತೀವಿ, AC ಮತ್ತು DC ಎರಡು ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರು. ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್ ಮತ್ತು ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್. Alternating current, it means the current which magnitude varies periodically, simple harmonically, sinusoidally, and also its direction, reverse its direction periodically. Such a type of current is said to be alternating current. Now this is go to the next chapter, that is said to be alternating current. You got the expression for the alternating current. I is equal to I naught sin omega t. Now omega is said to be angular speed, angular velocity. T is the time. I naught is the peak value of current. Peak value of current you got E naught divided by R, NA omega B divided by R. Here N is the number of turns in the armature coil. A is the area of the coil, omega is the angular frequency or angular velocity, B is the magnetic field, R is the resistance of the coil. Now you got few expressions for the alternating current. Now this is the time period, frequency and all these things. Okay, thank you. My dear students, now in this video clip I discuss about the definitions about the alternating voltage or is said to be alternating current. ಕೆಲವೊಂದು ಡೆಫಿನೇಷನ್ಸ್ ಏನು, ಆಲ್ರೆಡಿ ಯು ನೋ ದಿಸ್ ಒನ್. ವೋಲ್ಟೇಜ್ ಆರ್ ಕರೆಂಟ್ ಆರ್ ಇಸ್ ಸೆಡ್ ಟು ಬಿ EMF ಆರ್ ಕರೆಂಟ್ which varies sinusoidally or simple harmonically. that expression for the EMF E is equal to E naught sin omega t, then current is I naught sin omega t. Okay, now here in the next class, instead of EMF you represent E, instead of E I want to write here, instead of E I want to write here V. At that time V is equal to what you got, V naught sin omega t. ಇಲ್ಲಿಂದ ಮುಂದೆ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಈ ಬದಲಾಗಿ ಫಿ ತಗೊಳ್ತಾ ಹೋಗ್ತೀನಿ. ಈ ಚಾಪ್ಟರ್ ಮುಗಿತ ನಾನು ಯಾವ್ದನ್ನ EMF. Now what are the definitions, few definitions about this one. Already you know this one, whatever the EMF or current. Okay, now this is E or P, which varies sinusoidally or simple harmonically. ನಾವ್ ಏನ್ ಹೇಳ್ತೀವಿ, ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿದೆ ಎಲ್ಲಿಂದ, ಇದು AC ಜನರೇಟರ್. AC ಜನರೇಟರ್ ಒಳಗ ಅಂತಂದ್ರೆ ಅದು ಏನಾಗುತ್ತ, ಆರ್ಮೇಚರ್ ಕಾಯಿಲ್ ರೋಟೇಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತಾ, ಅದಕ್ಕೆ ಟೈಮ್ ಪೀರಿಯಡ್ ಇರುತ್ತೆ, ಇಂತಿಷ್ಟು ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂತ ಇರ್ತದ, ಇಂತಿಷ್ಟು ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಇರ್ತದ, ಆಮೇಲೆ ಇಂತಿಷ್ಟು ಆಂಗ್ಯುಲರ್ ಸ್ಪೀಡ್ ಅಂತಾನು ಕೂಡ ಅದಕ್ಕೆ ಇರುತ್ತ. ಎಸ್ ಫೈನ್. ಇವಾಗ what are the important definitions now? See here, the frequency. Now what is frequency of AC? Number of AC cycles per second is called frequency of AC. Number of AC cycles per second or number of rotations of the armature coil in the AC generator per second is also called as a, that is said to be frequency of AC. It is measured in CPS, cycles per second, or is said to be hertz, that is said to be Hz. It is represented by F or nu. Okay, in your India, you in a power station, you that is generate the power, electrical power. The frequency in India about that is said to be 50 hertz. What is meant by this one? Number of cycles per second in the generator, hydroelectric power station, or is said to be thermal power station. Anywhere you have to take here. At that time, that is the frequency is 50 hertz. A frequency ಎಷ್ಟು ಇರುತ್ತಾ, 50 hertz ಇರುತ್ತಾ ಇಲ್ಲಿ ಇಂಡಿಯಾದೊಳಗ. ಸರಿ, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಪೀರಿಯಡ್. ಟೈಮ್ ಪೀರಿಯಡ್ ಏನು, ನಾವು ಇಲ್ಲಿ ಆಂಗ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಏನಾಗುತ್ತಾ, ನಾವು what you got the angular frequency? Angular frequency you got omega is equal to 2 pi f ಆಗುತ್ತಾ, or is said to be 2 pi nu ಅಂತ ಹೇಳ್ತಾನೆ. Okay, what is time period? The time period of an AC is the time taken for one cycle of AC, or time taken for one revolution of, that is rotation of the armature coil, that is called time period. Time taken for one oscillation. Yes, F is equal to 1 upon T, or you said to be T is equal to 1 upon F. Then time period in India hydroelectric power station, or you said any power station, 1 divided by 50. What you got here? 0.02 second. 0.02 second is the time period of an AC in India, whatever you generate the electrical power. Then you got the peak value, the maximum value of voltage or current. No, alternating current, the maximum value attained on either half cycle of AC. For either half cycle of AC, that is called peak value. ಅಂದ್ರೆ ಇಲ್ಲಿ ಐದರ್ ಪಾಸಿಟಿವ್ ಸೈಕಲ್ ಅಂತ ತಗೊಳ್ಳಿ, ನೆಗೆಟಿವ್ ಸೈಕಲ್ ಅಂತ ತಗೊಳ್ಳಿ. ಇದು ನಾವು ಪಾಸಿಟಿವ್ ಸೈಕಲ್ ಅಂತ, ಇದು ನೆಗೆಟಿವ್ ಸೈಕಲ್ ಅಂತಾನೆ. ಫಾರ್ ಐದರ್ half cycle of AC, how much maximum value attained by EMF or voltage or current, that is said to be peak value. That peak value is represented by P naught. EMF or voltage is represented by P naught, and current is represented by what you say I naught. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ P naught ಏನಂತ ಬರೀತೀವಿ ನಾವು, ಆಲ್ರೆಡಿ ಯು ನೋ ದಿಸ್ ಒನ್. I naught NA omega B, and I naught is, that is NA omega B divided by R. What is the number of turns in the armature coil? What is A? Area of the coil, and omega angular speed or angular velocity, and B is the magnetic field. Now what is R here? Electrical resistance of, that is the coil. Now we come to the mean value or average value. Mean value or average value ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಡಿಫೈನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಚಾರ್ಜ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೋತೀವಿ. ಹೇಗೆ ಚಾರ್ಜ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೋತೀವಿ? DC ಸರ್ಕ್ಯೂಟ್ ನಾವು ನೆನ್ಪಿಡ್ಕೋಬೇಕು. The mean value or average value of a current. Current ಅಂದ್ರೆ ಚಾರ್ಜ್ ಸೆಂಡ್ ಮಾಡೋದು. I is equal to Q divided by T. the amount of alternating current which send the charge in either half cycle of AC is same charge sent by the current in the DC circuit in the same time for either half cycle of AC. This is called mean value or average value of AC. ಹಂಗಂದ್ರೆ ಏನು ಎವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ AC ಅಂದ್ರೆ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಹಾಫ್ ಸೈಕಲ್ ಆಫ್ ಎಸಿಗೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಸೆಂಡ್ ಮಾಡುತ್ತೆ ಅಷ್ಟೇ ಸಮಯದಲ್ಲಿ ಡಿಸಿ ಕರೆಂಟ್ ಡಿಸಿ ಸರ್ಕ್ಯೂಟ್ ನೊಳಗ ಅಷ್ಟೇ ಸಮಯದಲ್ಲಿ ಅಷ್ಟೇ ಚಾರ್ಜ್ ಸೆಂಡ್ ಮಾಡಿದ್ರೆ ಆ ಡಿಸಿ ವ್ಯಾಲ್ಯೂ ಇದೆ ಅಲ್ಲ ಕರೆಂಟ್ ಅದು ಏನದು ಎವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್. ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು, ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಹಾಫ್ ಸೈಕಲ್ಗೆ ಅಷ್ಟು ಟೈಮ್ ನೊಳಗೆ ಹಾಫ್ ಸೈಕಲ್ ಟೈಮ್ ನೊಳಗೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಸೆಂಡ್ ಮಾಡುತ್ತೆ. ಸೇಮ್ ಚಾರ್ಜ್ ಸೆಂಡ್ ಬೈ ದಿ ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್ in the circuit in the same time. Now that alternating that DC current, that is a DC current, that is called mean value or average value of AC. Direct expression, average value or mean value of voltage 2 upon pi V naught. V naught is the peak value. Current, mean value of current 2 divided by pi I naught. I naught is the peak value. 2 upon pi 0.636. Now you got the value. Vm is equal to 0.636 V naught and Im is equal to 0.636 I naught you got. Okay, what is the root mean square value? Now root mean square value define ಮಾಡಬೇಕಾದ್ರೆ heat produce concept ತಗೋಬೇಕಾ, ಇಲ್ಲಿ ಪೀಕ್ ವ್ಯಾಲ್ಯೂ ಹೇಳಬೇಕಾದ್ರೆ ಚಾರ್ಜ್ ಸೆಂಡ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಳ್ತೀವಿ ನಾವು. ಚಾರ್ಜ್ ಏನು ಕಳಿಸ್ತದಲ್ಲ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಚಾರ್ಜ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಂಡು ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, ಹೀಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಳ್ತೀವಿ. ವಾಟ್ ಇಸ್ ರೂಟ್ ಮೀನ್ ಸ್ಕ್ವೇರ್ ವ್ಯಾಲ್ಯೂ? ದ ರೂಟ್ ಮೀನ್ ಸ್ಕ್ವೇರ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ AC is the direct current which produce the heat same as the heat produced by, that is the alternating current in the same time in the same circuit. Once again I repeat, the root mean square value of AC alternating current is the direct current which produce the heat same as the heat produced by the alternating current in the same circuit in the same time. This is called, that is the root mean square value. Heat produce concept ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ RMS value define ಮಾಡ್ತೀವಿ. Now RMS value of voltage, it is given by P naught by root 2 and IRMS I naught by root 2. Now 1 by root 2 value 0.707. At that time VRMS, that is said to be VRMS is equal to 0.707 V naught and IRMS is equal to 0.707, that is I naught. ಇದರ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? ಇಷ್ಟು. ಅವಾಗ ಅಬ್ಸರ್ವ್ ಮಾಡೋಣ ನೋಡಿ. ಇವಾಗ ಇಲ್ಲಿ ಇದರ ಒನ್ ಸೆಕೆಂಡ್ ರಿಪೀಟ್, ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಅವರೇಜ್ ವ್ಯಾಲ್ಯೂ ತೊಗೊಳ್ದಾಗ ಚಾರ್ಜ್ ಸೆಂಡ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೋಬೇಕು. ರೂಟ್ ಮೀನ್ ಸ್ಕ್ವೇರ್ ವ್ಯಾಲ್ಯೂ ತಗೊಂಡು ಹೇಳ್ಬೇಕಂದ್ರೆ ಹೀಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಂಡು ಹೇಳಬೇಕು. ಇಲ್ಲಿ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡೋಣ. ಇದು 0.636 V naught ಇಂದ ಗುಣಾಕಾರವಾಗಿದೆ, ಬಟ್ ಇದು 0.707 ಇಂದ ಗುಣಾಕಾರವಾಗಿದೆ. ಅಂದ್ರೆ VRMS ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಎವರೇಜ್ ವ್ಯಾಲ್ಯೂಕ್ಕಿಂತ ಇದು ಹೆಚ್ಚು, ಇದು ಹೆಚ್ಚು, ಇದಕ್ಕಿಂತ ಇದು ಹೆಚ್ಚು, ಇದಕ್ಕಿಂತ ಪೀಕ್ ವ್ಯಾಲ್ಯೂ ಹೆಚ್ಚು. How it is related? Peak value of voltage or current is greater than the RMS value. RMS value is greater than the average value or setting mean value for voltage and current. When you draw the sinusoidal graph, now your voltage or current with the time along what is x axis and voltage or current along the y axis. Now it is the peak value. ಯಾವಾಗಲೂ ಇದರ ಅರ್ಧ ಬರುತ್ತಲ್ಲ, ಅರ್ಧಕ್ಕಿಂತ ಮೇಲೆ ಇರಬೇಕು 3 ವ್ಯಾಲ್ಯೂ. ಇದು ಅಲ್ಟಿಮೇಟ್ ಮೇಲೆ ಬರುತ್ತೆ, ಎಲ್ಲೇ ಪೀಕ್ ವ್ಯಾಲ್ಯೂ. ಅದ್ರ ನೆಕ್ಸ್ಟ್ ಯಾವ್ದು ಬರ್ತದ? RMS ವ್ಯಾಲ್ಯೂ ಬರ್ತದ. ಅದ್ರ ನೆಕ್ಸ್ಟ್ ಬರುತ್ತೆ ಎವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಅಥವಾ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಆದರೆ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಇದರ ಅರ್ಧ ಇದೆ ಅಲ್ಲ, ಅರ್ಧಕ್ಕಿಂತ ಮೇಲೆ ಇರಬೇಕು ಇದರ ರೆಪ್ರೆಸೆಂಟೇಷನ್. ಯಾವ್ದು? ಪೀಕ್ ವ್ಯಾಲ್ಯೂ, RMS ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ ಮೀನ್ ವ್ಯಾಲ್ಯೂ. ಪೀಕ್ ವ್ಯಾಲ್ಯೂ ಆದ್ಮೇಲೆ RMS ವ್ಯಾಲ್ಯೂ ಬರಬೇಕು, RMS ವ್ಯಾಲ್ಯೂ ಆದ್ಮೇಲೆ mean value ಬರಬೇಕು. ಯಾಕೆ RMS value because it is multiplied by 0.707 but mean value is 0.636 but 0.5 ಕಿಂತ ಮೇಲೆ 0.5 ಕಿಂತ ಅರ್ಧದಕ್ಕಿಂತ ಮೇಲೆ 3 ವ್ಯಾಲ್ಯೂ ಬರಬೇಕು. ಇದು representation. And phase ಅಂದ್ರೆ the phase of the voltage or current, it is the value of the fractional value of current at any instant of time that indicate the phase. Okay, thank you. Good evening my dear students. Now today I discuss about that is the alternating voltage source is applied to the pure resistor. Already you know this about the AC source, that is said to be alternating current source. Now that alternating voltage across the AC generator, it is at any instant of time, instantaneous voltage P is equal to P naught sin omega t. It means that EMF or voltage which is varies sinusoidally and simple harmonically. Now the alternating current is also given by I naught sin omega t. Here omega is equal to 2 pi f. What is f? F is the frequency of AC. Now this is the angular velocity. Now this is the instantaneous current. This is said to be peak value of current, and omega is equal to 2 pi f. F is said to be frequency. That frequency is also is equal to reciprocal of the time period. Our time period is equal to reciprocal of the frequency. You know this one. These points. Now this value of the magnitude of the current which varies simple harmonically and periodically, and also reverse its direction periodically. ನಾವು ಹೀಗೆ ತಗೊಂಡಿದ್ದು ಮತ್ತೆ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಮತ್ತೆ ಹಾಫ್ ರೊಟೇಷನ್ ಗೆ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಪೀರಿಯಾಡಿಕಲಿ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಇದಕ್ಕೆ ನಾವೇನಂತೀವಿ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ವೋಲ್ಟೇಜ್ ಅಂತೀವಿ, ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಅಂತೀವಿ. ಆಮೇಲೆ ಆ ಎಸಿ ಸೋರ್ಸ್ ಇದೆ ಅಲ್ಲ, ಎಸಿ ಸೋರ್ಸ್ ಯಾವಾಗಲೂ ಹೀಗೆ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ತಾರೆ. ಅಂದ್ರೆ ಈಗ ಎಸ್ ಮಾರ್ಕ್ ಹಾಕಿಬಿಟ್ಟು ಹೀಗೆ ಬರೆದ್ರೆ ಏನಿದು ಎಸಿ ಸೋರ್ಸ್. ಇದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ ಎಸಿ ಸೋರ್ಸ್. ಡಿಸಿ ಸೋರ್ಸ್ ಹೀಗೆ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ತಾರೆ. ಈ ಕಡೆ ಪಾಸಿಟಿವ್, ಈ ಕಡೆ ನೆಗೆಟಿವ್. ಆಮೇಲೆ EMF ಬರಿತೀವಿ, ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬರಿತೀವಿ. ಇದು this is said to be DC source. Here there is a polarity is positive and negative, but in the case of AC source there is no polarities. It means there is no sign conventions positive and negative. ಹೀಗೆಲ್ಲ ಇರೋಲ್ಲ. Why? Because for each and every half cycle of AC change its direction, therefore change its polarity. That polarity is not constant. It is not always positive, it is not always negative. Because of this reason you don't assign the polarity, or you say to be sign. Now you apply the alternating voltage. There are important mainly 3 components. First you have to apply the alternating voltage applied across the pure resistor. This is first point. And then what is the EMF, that instantaneous voltage equation? What is the instantaneous current equation? What happens? How it behave like this? What is the power in the AC circuit which containing, that is the purely resistive circuit. Now these are said to be AC circuits. Beginning in current electricity, all the circuits are DC circuits. But here we have to take AC circuits. Why? Because you use that is AC source. For this reason, what you say? Now this is said to be AC circuit. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ ಇದಕ್ಕೆ AC circuit ಅಂತ ಹೇಳ್ತೀವಿ. Now the AC source is applied to the pure resistor. This is the R here, pure resistor. Now what happens? Now when you, for the AC circuit, you always you draw the phasor diagram and variation of the voltage and the current. Voltage ಮತ್ತು ಕರೆಂಟ್ ನಾವೇನ್ ಮಾಡ್ತೇವೆ ಅಂದ್ರೆ ಎರಡನ್ನೂ ನಾವು ವೇರಿಯೇಷನ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ತೀವಿ. ಮತ್ತೆ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಯಾವುದು ಅಂದ್ರೆ ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ಕೂಡ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ತೇವೆ. Now what happens? Now see here. Now AC source is applied to the pure resistor. What happens? Now see here. Now AC source is applied to this one. Then what happens here? Now here applied voltage across the resistance, that is the AC source, P is equal to V naught sin omega t. Equation number 1. Here P is instantaneous value of voltage. It is the voltage across the resistance at any instant of time you apply it. P naught is what you say peak value of voltage. Then omega is said to be angular frequency. This is said to be 2 pi f. Now come to the point. Now by Ohm's law, by Ohm's law, what you have to write here? That is P is equal to I into R. R is the resistance. P I R. Now instead of P you substitute I R. Then V naught sin omega t. Got the instantaneous values. Instantaneous values, it means here one value, here another one, another. It is not steady. It is in a positive half cycle of AC. And negative, again negative half cycle AC, there is a different values of voltage and current. See here, that instantaneous value of current, what you got here? You take V naught divided by R sin omega t. Instead of V naught divided by, according to Ohm's law, this is said to be I naught. I naught is said to be peak value of current. Now this is the expression for the current in pure resistive AC circuit. This is the expression for the voltage in the pure resistive AC circuit. What happens? Now see here, both are said to be in phase. Both are said to be in phase. In phase it means there is no phase difference between voltage and the current. Voltage ಮತ್ತು current ಮಧ್ಯೆ ಯಾವುದೇ ತರಹದ phase difference ಇಲ್ಲ. ಇಲ್ಲೇ ಪ್ಲಸ್ 90 ಡಿಗ್ರಿ ಬಂದಿದ್ರೆ phase difference 90 ಡಿಗ್ರಿ ಅನ್ಬೋದು. ಪ್ಲಸ್ 45 ಡಿಗ್ರಿ ಬಂದ್ರೆ phase difference 45 ಡಿಗ್ರಿ ಅನ್ಬೋದು. ಇದು ಹೀಗೆ ಇದೆ ಅಂದ್ರೆ now this is the phase difference is 0. It means voltage and current both are in phase in the pure resistive circuit. Pure resistive circuit ನೊಳಗ voltage current in phase ಇರುತ್ತೆ. Phasor diagram ಇವರು ನೀವು. What is the meaning of the phase difference is 0? It means both the current and voltage attain the maximum value at the same time. Both voltage and current which are reach the zero value, minimum value at the same time. It means there is no phase difference between voltage and the current. It means voltage and current both are in phase in the pure resistive AC circuit. Our phasor diagram draw ಮಾಡಿದಾಗ ಇಲ್ಲಿ at any instant of time ತಗೊಳ್ಳೋಣ. ಅವಾಗ corresponding voltage P naught sin omega t. Corresponding that current I, that is said to be I naught sin omega t. In phasor diagram, it is a V, it is a I. It means magnitude of V is greater than magnitude of V, voltage is greater than magnitude of the current. That is the meaning of this one. Their magnitude for this particular time, this is the magnitude of the current, this is the magnitude of the voltage. And once again I repeat, in the pure resistive AC circuit, both voltage and current, they are in phase. Phase difference between voltage and current, they are 0. Okay. Now what is the power in purely resistive circuit? In next video clip, I want to explain about that is the power in purely, that is said to be AC circuit. Okay. Thank you.